Okay, today is our Wednesday schedule, and today we went over a couple things. Some classes we finished our vocabulary, and then we did a little maze race. Okay, everybody got prizes. The first three got prizes. So what you did is decided what kind of angles they were, if they were equal. So we're trying to decide if they're equal. No, that's the other side. We're trying to decide what they are. If this is alternate interior or vertical. These look vertical, but they're on two different parallel lines. So this is exterior, this is exterior, this is on the right, this is on the left. So this is alternate exterior. So we would highlight from our start, we go this way. And so now we're looking at this one. These two are interior, they're on the inside. So that says exterior, this says interior, and this one says interior. So I know that one's not right. Let's see, this is on the right, this is on the left. So they have to be alternate, not same side, okay? So I'm going from here to here. These are some good test-taking skills. Eliminate what you can, all right? This one, they're on the same side. So that says same side. That does not, so I'm gonna go with same side interior. Okay, corresponding would have been if this is here, it'd have to be up there. There's not. So same side, now we're looking at these two. These are also same side. But this one's exterior, this is interior, so it can't be that one. Can't be that one. But it can be corresponding because this is on top of the parallel and to the right of the transversal. This one's on top of the parallel to the right of the transversal, so it's corresponding. These are vertical. That should be the easiest one. They're right across from each other. This one is either going to be corresponding, alternate interior. Oh, shoot, I erased that, and it could be same side. Let's look. They're both inside, so it has to be interior. Oh, that one says exterior, so it can't be that one. So it has to be this one, and they are on alternating sides. These are, if I turn it this way, I can see it a little bit better. Same side, but this is exterior, this is interior. This is above the parallel, this is above the parallel, this is to the left, so they're going to be corresponding. Okay, we know this vertical. Okay, let's turn it back this way a little bit. Let's see, here's my transversal. This is to the right, this is to the left, so it's going to be alternate. There's alternate. And they're exterior, so we're going to alternate exterior. This one is below the parallel, to the left, so corresponding. And yay, we finish. Okay, we had a little race and did this in class, just to kind of help us remember the names of the pairs. For tomorrow is an e-learning day, so this is what everyone's going to do tomorrow. Okay, we did the first one together. So again, we're going to start with our start, and I gave everyone a sheet to record their work, maze work paper. So you're going to do the first one. So this is number one, so we're going to label it number one. And we need to decide one of two things. These are either going to be congruent, so that's equal, or they're going to be supplementary. Okay, these are our only two choices for all of these. Okay, you're going to look at the angle pair, and you're going to decide if it's congruent or all supplementary. You can do that by knowing the names of the angle pairs and knowing if they're congruent or supplementary. I like a quick visual. I like to do my X's and O's. I didn't really have to do it down there because I just had all my numbers up here. I know that these two are vertical, and you can tell this is a obtuse angle, this is an obtuse angle. See how those are the same? So that means these are the same. So what I'm going to do is I'm going to set them equally together. So if they're congruent, the formula I use is angle 1 equals angle 2. So I can say this is angle 1, this is angle 2. It doesn't really matter which order you put them. 3x minus 1 plus Is angle 1? Nope, 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 not plus. 3x minus 1 equals, these are equal to each other, equals second angle x plus 5. Then I just have a multi-step equation. I'm going to move my x over here, so I'm going to do minus x on both sides. Oops. I like to keep it nice and neat there. Draw my line here, so this would be 2x minus 1 equals 5. I'm going to add 1 to both sides to get rid of my 1. Now I have 2x equals 6. I'm going to divide by 2. X equals 3. Okay, let's look. Here's an answer, here's an answer. Well, it's not 2, it's 3. So I'm going to go this way. So this is now going to be number 2. Okay, so we're going to go to 2. And we're going to look, and again, I don't care how you do it. If you've got highlighters at home and want to highlight it to see which are the same and which are different, you can do that. I like, to me, it's real quick to do X, 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 O, 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 O. And I can see this is orange, this is pink. This is O, this is X. So I know with supplementary, this is my X plus O equals 180. So it's angle 1 plus angle 2 equals 180. I can do this one 1 and this one 2. And this would be, no pencil. Well, you can probably see better. 8x plus 10 plus, because that's what's in the middle, 6x plus 2. Now you do not have to write the actual parentheses. If you do, to me, it kind of makes it more complicated. Because we're not really doing the parentheses. The only reason they had the parentheses there is they didn't want to write a degree sign there and there. So they're just showing this is one expression, this is the other expression. Okay? If you don't have the parentheses, it makes it a lot easier to see what to do. Okay? So just drop the parentheses. It's not distributive property. They're just doing it for a reason. So now I see that I have an 8x and a 2x. 8x and 6x. That's 14x. I have a 10 and a 2. So these are like terms. There's no variable. So that's plus 12 equals, and I forgot up here, I have to have that equals 180 or I can't solve. Okay, now I can take 12 away from both sides. 14x equals, let's see, 2 minus 10 is 8, so that's 168. If I divide both of those by 14, I get some number. Do I have, let's see, 14 goes into 16 one time, goes into 28 2 times, so x equals 12. Let's see if there's a 12. Well, I've got 4, it's not 4. Oh, look, that 12 has a negative. I didn't do a negative. So it's got to be this one. So I'm going to go this way. So now, this is number 3. You're going to do the rest. All right? I'll have a video going over all of them if you need help on Friday night. Because this is due on Friday, so everybody turns it in on Friday. So that is that worksheet. Okay, here you're just finding the direction. Here you are actually working out each problem. And you won't have to do every single box. There'll be some boxes that won't be in the maze. And if they're not in the maze, you won't end up having 12. All right, so that was one assignment. Now the next assignment, we went over a couple blue notes. The first one was a sheet about angles, and I had everybody take about 5 minutes to write down everything they knew about any of these words. And what it's talking about is angles. There's more than one way to describe an angle. If we're talking about just one angle, it can be acute, which would be a small angle. That would be less than 90 degrees. Obtuse would be big angle. It's over 90 degrees. A right angle has a right, usually has a box there, and it says 90 degrees. So a right angle is always 90 exactly, not less, not over. Straight angle is just a line, and that equals 180 degrees. Okay, when we talk about angle pairs, that's two different angles, two angles together. So if we have complementary, that's two angles that equal 180. Angle 1 plus angle 2 equal 90, not 180, I'm sorry. That's supplementary. Supplementary is angle 1 plus angle 2 equals 180. Linear pair is the same thing. It is a supplementary angle. Vertical or congruent. Okay, they're equal to each other. Adjacent, that means they're just side by side. Here and here. Or if I have it this, here and here. They share a line. Okay? Now, when you talk about angles, so sometimes when I say, okay, what are these two angles? I hear a lot of acute, obtuse. But when we're talking about angle pairs, these are the words we're describing. Or we're using these words. These words only come into play when we have parallel lines that are cut by transversal, because that creates 8 angles and 4 new types of angle pairs. Alternate interior. So if I did that, that'd be here and here. Alternate exterior, be here and here. Corresponding, here and here. Now there's other options too. Consecutive interior, which is the same as same side, would be those two. Now they would also be, alternate interior would also be here and here. Alternate exterior could also be here and here. Corresponding could also be here and here. It could also be here and here, up there, and then there and there too. So there's lots of different corresponding, because it can be interior and exterior. Consecutive can only be there or here, because I can't have consecutive exterior because that would be out here and there'd be angles in between. Okay, when I have a perpendicular line as my transversal, and it goes straight up and down, I have not 4, but 8 right angles. All of these are right angles. Okay, but they're still the same. I still have alternate exterior, alternate interior, corresponding here and here, consecutive interior. So they're still called these things, but they're all equal to 90 degrees. So they're all also supplementary. Now, we know that angles create triangles. There are 3 types of triangle, or 4. I forgot to write one right here, right triangle. Okay, an acute triangle has an acute angle. Well, I don't want to draw it with a right angle. Let's see. Draw it like this. Has this, they're all acute angles. Okay, that means they're all less than 90. All right, and a right angle has one 90 degree, and then these others are going to be a different degree. Has one right angle. This has all acute angles. An obtuse triangle. Now, what we're doing on these is we're describing the triangle by the angle. Obtuse, that means we have an obtuse angle that forms this triangle. We also have 2 acute, but because we're talking about the main angle is obtuse. Equilateral means all the angles are exactly the same. And I may not be drawing it exactly, but all of these are going to be the same degree. So that'd be like 60, 60, and 60 degrees. All right, if we talk about triangles by their side, equilateral, that means if this is 5, and this is 5. All the sides, all 3 sides are equal. Okay, if I'm talking about isosceles, okay, this side and this side are equal. So 2 sides are equal, but the third side is different. In a scalene, well, I don't know what it looked like, but this would be 6, this may be 8, and this might be 12. All the sides are different. All sides different. No equal sides. Okay? Now, after we talked about triangles a little bit, we took a pipe cleaner and we looked at what it made if we just held it nice and straight. Okay, this is just a straight line. How many degrees is a straight line? We could also call it a straight angle. If you said 180, you're right. All right, then I told everybody to make a triangle. So you had to bend it to form 3 angles. And we had some different kind of triangles created, some very good ones. But now I have one angle here, one angle here, and one angle here. So my question was, now that I've taken my straight angle and made a triangle, how many degrees are inside the angle? Okay, we don't know exactly how much this one and this one and this one is, but we know that if we add them together, they're going to equal 180. Because look, if I take my triangle apart again and stretch it out, I have a straight line, and that's 180. So that's the only option for these angles. No matter what kind I make, okay, I can make the one that looks like this, maybe. Okay, I can make one with a really short side and a long hypotenuse, okay? Even this one is gonna be 180 degrees. If I took a protractor and I measured this angle, and this angle, they're gonna equal 180, okay? What we just discovered is called the triangle sum theory, okay? Triangle sum theory. The measure, that's what that M stands for, the measure of angle 1 plus the measure of angle 2 plus the angle of measure 3 equals 180. And it doesn't matter what type of angle, whether it's right, obtuse, acute, equilateral, scalene, isosceles, no matter what kind of triangle, all I have to do is add up all 3 angles and it equals 180 every single time. Okay, let's look at this one. We have x, because we don't know what that angle is, but we know this is 117 and this is 38. So what I can do is I can go 117 plus 38 plus x. Okay, that's angle 1 plus angle 2 plus angle 3. Now I can just number them. Here's 1, 2, well, I did it like this. I did 1, 2, and I made this one 3. Doesn't matter what order. I can write it 38 plus x plus 117. As long as I'm adding all these, I get 180. Now, I can add these two together and get 155 plus x equals 180. Then I can subtract 155, and I'm going to get 25. So x equals 25. Another way you could do it is I could take 180 and subtract 117 and then subtract 138. Or I can add 117 and 138 together, which is my 55, and subtract 155, which is what we did when we did the equation. But on these, they're a little bit easier. You don't necessarily have to write down the equation. But once we get to ones like these, you're going to have to. Now, I'm going to tell you, we're not going to practice these today. We're going to practice these on Friday, but this is what your homework will be. Okay, there's a sheet, and I don't think I have it over here, that has like a snake that has lots of different triangles that make up his body, and every triangle is missing an angle. So you have to fill in the different angles to put him together. And did I just find one? No. I don't have one with me, but I will post a picture of one so that if you weren't at school today, you can still do it. Okay, so let's just go ahead and talk about this though. If I name this angle 1, this angle 2, and this angle 3, then all I do is I do angle 1 plus angle 2 plus angle 3. So I do 2x plus 4 plus, I'll just go and put my plus signs. 2x minus 9 plus x equals 180. That's angle 1 plus 2 plus 3. All right, then I can clearly see, this is simplified. I need to simplify this side. So I've got a 2x, and an x. So that's 2, 4, 5, x. Okay, I've got a 4 and a minus 9. So 4 minus 9 is negative 5 equals 180. I add 5 to both. 5x equals 185, and when I divide, x equals 30, I think somebody said 37. 37. Oh, yep, 37. And the way I can check that is, I would have 37, because that x is 37. I would have 2 times 37, which would be 74 minus 9 would be 65. So this would be 65. So 37, 65. And then 2x, 2 times x would be 37 and 37. Oh, I did that right here. So it'd be 74 plus 4 would be 78. So I could do 78, and I add these together. So 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, 180. I got it right. See, just like equations, you can check yourself. Because once you find x, you just plug it into your expressions and find those values and plug it into your calculator really quickly to make sure you're right. Okay, also on the sheaves, this is a piece of cake. Remember that in an, I can't even say that word, but it's like an equilateral triangle. Each angle is 60 degrees. Why does that make sense now? Because 60 plus 60 plus 60 equals 180. Okay, let's do this last one together. Find x and y. Okay, we've got y and we've got x and x. All right, I haven't actually tried this one, so we'll wait on try this one on Friday. And also on Friday, we're going to discover the exterior angle theorem. All right, so for our homework, for our e-learning day, you're doing this maze, you're doing this one, and then you're going to write your answers in this box here. Let me see if I can find that snake real quick. So you know what it looks like, but I will also post a picture of it. So if you don't already have it at home, you can draw it out or just draw the different X's and find it. Well, I can't find it. I don't know where it is. I've been looking for it all day. I always put it in a different location. But it looks like a snake. Oh, I know where. Nope, not there. I wonder why it's not here. Oh, well, I'm not gonna keep looking. We'll see you on Friday.